We are team number 29 with the honors lab. My name is Deepika Bashar.
And I'm Brian Zhang.
This is our 8-bit calculator from scratch. We're going to talk about each of the components separately. We first have an input. We used photoresistors that are connected in a voltage divider with a 47K ohm resistor and AND gates. One of the input of the AND gates are connected to high, so they're high at all times. And when we block one of the photoresistors, we get an output of high. This then gets transferred onto the bus, which is then connected to the bus transceiver here. This bus transceiver is connected to a 32K byte RAM and is then connected to a 4-bit dip switch here that allows us to change or manipulate the address.
So then here we got an inverter, and this inverter helps us condense the operations of read-write mode and bus to RAM and RAM to bus modes into a single operation, and that's controlled by this wire here, whether we put it onto the ground or high. And finally, this little button here that allows us to write onto the RAM whenever the RAM is on write mode. And here are 8 LEDs that indicate the whatever data is on the RAM module. And so over here in the middle, that's going to be our bus, and here we have 8 blue lights, blue LEDs indicating the state of the bus. And on the right here we have 2 registers, 2 8-bit registers, as well as an 8-bit full adder. And so in the top register we have once again a bus transceiver. So this bus transceiver currently is not being used right now, but we'll be adding on to that later after the semester if we can. And the same goes with this bottom one. So these 2 registers are really the same things. So, and then on these 2 register boards we have 2 4-bit registers, and that's going to allow us to store 8 bits. Same with the one on the bottom. And in the middle here, this jumble of wire, so this is our ALU, arithmetic logic unit, and once again there is a bus transceiver that allows it to communicate with the bus. And towards its left are 2 4-bit full adders, and then to its right we have 2 XOR gates. And so the reason why we have these XOR gates is that allows us to control whether or not we want to add or subtract the number on B from A. So if this black wire here is set to low, that means these 2 boards, whatever the data are on these 2 registers, are going to be added together, and the register is on, if this is on high, this one is subtracted from this board. And finally, we have 8 result LEDs from the ALU, and this blue light here represents a carry. Now on the other hand, this blue light is also used as an indicator for subtraction. So if we're doing a subtraction, this blue light will be on to indicate that we're doing a subtraction. Alright, so here Deepika is going to demonstrate addition and subtraction. So first we're going to add 2 numbers and then subtract 2 numbers. First number we're storing in the RAM is 170. The second number here is going to be 85. So that's going to be adding up to 255 for the first 2 addresses. And then for the third address, we're going to be storing 15. And the fourth address, we're going to be storing 5. So we're going to be subtracting 5 from 15 at the end here. So now what we're doing is we're disconnecting the input, and we're turning the RAM into read mode. And so currently we're going to store the first register of the RAM to register A, the second address of the RAM to register B. You can see that we've added them up to 255 here. And so second second operation, we start with 15, which on the third address, and 5 on the second register. And so 15 minus 5 gives us 10, which is displayed by here. And here the blue light represents that we are subtracting.